My name is Ilya Benish, and I'm a carpenter for the Cold Climate Housing Research Center here in Fairbanks, Alaska. And in today's video, we're going to look at a way to get a little bit of extra energy performance out of a standard 2x6 framed wall system. So to start the video, we will look at this particular wall system and discuss how it works and why it works. Next, we will go to an actual job site and we will follow along what a contractor has done to make this wall system work. And then after that, we'll talk about a few other details that are very important if you are looking at actually building with this wall system. This house is being built by a local contractor who's done quite a few houses like this, and he has figured out a furring system on exterior walls that's worked very well for him. So we're going to explore some of the details. Before we discuss the furring, we're going to take a quick look here at the wall framing. And in this case, I mean, we're already measuring 5.5 inches to the edge of the window, so it's pretty safe to assume this wall has been framed with 2x8s. And that's very nice to see because, yes, the 2x8 framing does cost a little bit more, but it gives you a significantly deeper wall cavity to insulate. In this case, these walls were insulated with a blown-in fiberglass, and I would say by the numbers, this is about R30. I personally think blown-in insulations tend to yield better results because they fill in smaller size bays, anything non-standard. If the guys installing the insulation are good, you get very, very good performance. You get very uniform fill. By the numbers, this wall with R30 in the bays and 1.5 inches of furring with foam board insulation will yield a wall of somewhere between R35 and 40. That's a very good R value, especially in interior Alaska where we've got high fuel prices, and this home will be very, very energy efficient. And the next element we're going to look at in this wall assembly is our air and vapor retarder. And this is our industry standard 6mm poly, 6mm thick polyethylene plastic sheeting. What this poly does is it's a vapor barrier, and what that means is it stops moisture movement. This is the molecular movement of water through a wall assembly by diffusion. This is those water molecules moving through the studs, through the insulation over time, and then potentially condensing on the back side of the insulation. Any place you have sheeting overlaps here, you want to seal them. We typically use Tremco acoustical sealant, and in this case we're looking at a corner where one sheet ended and another started, and the contractor overlapped the sheets, and there's solid backing for the acoustical sealant, and this is really important. Any place you overlap sheets, whether it's where the ceiling meets the wall or one section on a wall meets another, you want to have continuous solid wood backing for that acoustical sealant. When you're looking at corners in particular, avoid bunching such that you have a tight corner and the plastic is stretched so that when the furring goes in, you're stressing the plastic and risking tearing it. You might not tear it right away, but you could come back a couple years later and you'll see that the plastic is torn and you've got an air leakage point. Some holes in the vapor retarder are going to be unavoidable, but the idea is if you can plan ahead where your holes are going to be, hopefully you can minimize the number of holes you're going to have to deal with. And here as an example, we've got a wiring penetration where we've got some wires that are running to the exterior. The nice thing here is that these wires are stapled right to a stud on the back side and then sealed. What that means is this wire isn't going to wiggle over time as it would if it were out here in the middle of the insulation bay. So long term, your odds of having a good seal here with this tape are much better than they would be out here in the field. So regardless of what that penetration might be, give some thought as to how you can seal that well and how well you can support the poly and the tape where that penetration is going through. So now we're ready to talk about the furring. And the first thing we need to consider is which way are we going to run the furring? Well, since walls are traditionally framed vertically, the furring goes on horizontally. The idea is the furring is perpendicular to the studs, and so the cross-sectional area here that you have where the furring actually contacts the stud is very, very small. That's great in terms of heat loss. But the question is, how far should we space the furring strips? In this case, the furring strips are spaced just under 24 inches. What that means is when you rip a sheet of foam board to put in here, you can rip it directly in half and it'll fit very nicely. There will be virtually no waste. This is another pointer. When you're setting your furring strips, once you've found out at what height you want to set your strips, before the plastic goes on, you can save yourself some heartache and snap chalk lines that represent the spot where every furring strip's going to go. Then when the plastic goes on, you've got a chalk line to follow and your furring strips get nailed on dead straight. Because we have 2 foot on center spacing, we're going vertical. That requires us to use 5/8 drywall. 5/8 drywall is stronger, and that's what's rated to go on 2 foot spacing. You cannot use 1/2 inch drywall by code on a 2 foot space. So when you're figuring out what you can get away with drywall spans, this is a great resource. This is the U.S. Gypsum Council's Gypsum Construction Handbook. It's full of great information, particularly what distances and what orientation you can use with drywall over furring. Once you've figured out which way your drywall is going to orient and your furring spacing, it's time to look at some of the details in a furring installation. One of the important ones here is that starting strip down there on the floor. Typically, we'll make it a 2x4 so you can securely nail your base trim in here. Base trim can be fairly tall, and if all you have is a 2x2, by the time you put your carpet and your pad in, there won't be enough nailing surface for that base trim. Also, if you're installing baseboard heating units, the plumbers are going to like you if you install a 2x6 here, because any place you're running baseboard, if you've got a 2x6, you've got a secure way of attaching those baseboard units. When we look at the furring strips here, they run along and they meet in the corner on a miter in this case. You might want to consider taking the points off the miter such that you don't have a sharp point jamming into the plastic in the corner. If there's plenty of slack in the plastic, it won't matter, but if the plastic's a little bit tight and you don't cut the corners off like this, I can pretty much guarantee you're going to stress that plastic and eventually it will tear. When we look at these electrical boxes, it's nice to keep the number of electrical boxes in the furring area to a minimum. The less electrical boxes there are, the less cutting and fitting with the foam board you have to do, and there's more insulation. This is very typical for this type of furring. It's a standard 1.5 inch thick. It's nailed on with 16-penny nails. The electrical boxes are a nice solid metal box. The deal here is we're not going deep, so if we have lots of wires in a box like this, we simply get a longer box and we adjust the height or the size of our cover plate. Here we are in the kitchen. Down in the lower part of the wall, we've got a couple of good details to discuss. One of them is the vent pipe here that goes through the polyethylene sheeting. The installers cut a small hole and just stretched the polyethylene right over this pipe and then taped it around. It makes for a very secure attachment. That's a nice detail. Also, for attaching cabinets, you need backing. For attaching towel bars, for attaching toilet paper roll holders, anything like that, you have to do a walkthrough through the house and figure out on those exterior walls if you need to put backing in anywhere. If you're putting a tub against an exterior wall, you might want to consider putting extra backing in there. In this case, this is going to give a place for the installers to attach the base cabinets. Also, when the subs are looking at the plans, if they're going to be pulling any measurements off of the exterior walls, they need to know they have to account for the furring. Case in point, if you're measuring to install a toilet drain, as a plumber, you need to know there's furring here such that your toilet isn't too close to the wall once it's all finished. Let's take a look up higher here. In the kitchen, we've also got a 2x4 up here at the top. That allows us to hang our upper cabinets, and the window has a 2x4, and that 2x4 extends past the edge of the window a little bit. This is done so that you've got a place to attach a curtain rod. If you've got bigger, heavier curtains, you may even want to hang this 2x4 out as much as a foot. So here we've got wiring going between floors, and it was necessary to drill through the furring. In general terms, the code wants to see 1.25 inches of solid wood before you get to wire. Otherwise, you're required to have nail plates. If there's any question about when you need nail plates, contact your code officials, or they'll point it out to you when they do a walkthrough. But this is good practice. Anytime you drill through the furring, put a nail plate in. Anytime there's anything critical, if you've got the supply wire to the house coming in, put nail plates in it anyway. That's just a good precaution. Here we can see at a break in between the 2x4 that's on the floor for the base trim, you can see a 2x2 has been nailed to the floor. This is an 1.5 inch thin slab radiant floor, and before this slab was poured, the contractor went around and installed an 1.5 inch by 1.5 inch square furring strip all the way around the outside walls. The idea being, A, you can screed your concrete off this furring strip, but you can also drill through it if you have to run wiring between the floors. When we look a little further over here, we can see it was necessary to run a wire downstairs, and having that wood furring strip there allowed the contractor to drill straight through. So once all the furring's in, then it's time to install the insulation, and virtually any type of 1.5 inch foam board will work in these furring spaces. In this case, the contractor is using Artec Insulfoam. The nice thing about this 4x8 sheet is it comes pre-scored, so if you space your furring strips appropriately, all you have to do is cut that. There's no table saw work that has to be done. Then the furring is spaced such that this sheet can be friction fitted right in there. That makes the process a lot quicker. The R value of this foam board is probably 6.5. That's effectively doubling the insulative value over the stud, so that's a pretty big gain in terms of a thermal break. In our climate, you do not want to add more than 1/3 of total wall insulation to the warm side of your plastic sheeting. That starts to cool that plastic sheeting such that it'll attract condensation if indoor air gets back there. With a wall R value of 30 on the cold side of the plastic and a foam board R value of about 6.5, that's a very safe insulation ratio. There's no concern of attracting condensation if warm air gets past the foam board and contacts the plastic. Hopefully in this video, we've been able to present the basics of installing warm side furring onto a wall assembly. I'd point out a few extra considerations. If you're doing furring for the first time in an area where your code official may not be familiar with it, it probably would be a good idea to get them on board early during the plan stage in case they have any questions. I think code officials are a lot like bears in that they don't like to be surprised, and if your code official comes in and sees the furring and hasn't seen it before, he may have a lot more questions than if you present the furring early on in the process. Other than that, I think the furring is a very quick, straightforward process that can yield some pretty big gains in energy performance and air tightness.